Hello guys, welcome to the channel. Today's Leetcode question is maximum width of a binary tree. So the question, given the root of a binary tree, return the maximum width of the binary tree. The maximum width of a tree is the maximum width among all levels. The width of one level is defined as the length between the n nodes, the leftmost and the rightmost null node, where the null node between n nodes that would be present in a complete binary tree extending down to the levels are also counted into the length calculation. Okay, let me first explain the question to you. The question says we have to take the maximum width from a level. Okay, so in this level we have just one node. In this level we have two nodes. In this levels, since we have three nodes, but the question also says that we have to consider the null nodes as well. Okay, where the null nodes between the n nodes that would be present in a complete binary tree extending down to the level are also counted. Here, in this case, we have three nodes, but we also have to consider two's left, which is null. So after considering two's left, which is a null node, our number of nodes would be 4. Here in the question, they have specified that we also have to consider null node only if it is present between two non-null nodes. Okay, this null node is present between non-null nodes, so we have to consider it. Okay, let's take this example. For understanding purpose, I am simply making null nodes and the children of null nodes. Okay. Here also 2 and 2 will also have its children null nodes. Okay, so in this level we have one node. In this level we have two nodes. In this particular level we will count 4 nodes. 2 are null nodes, 5 and 9 are 2 non-null nodes, and these two are null nodes. We also have to consider them as they are coming in between the non-null nodes. Okay, in this level, see, we are first counting 6. This node will be counted, this null node would be counted, this null node would be counted, this null node would be counted, this will be counted, this will be counted, 7 will be counted. But will this be counted? It's a question. So in the question it is clearly mentioned that we have to count the null nodes which come between two null nodes. This extreme null node do not come in between any two null. This extreme node do not come in between any two non-null nodes. Okay, if we would be having any null non-null node, then this would be counted. But since we cannot, we are not going to count this node into our answer. Okay, if we are not counting this null node into our answer, then what would be the width of this level? So 1, 2, 3, 4, 5, 6, 7. In this level, we'll be having 7 nodes. So this level's width would be 7. Let's consider this question. In this level, we have one node. In this level, we have two nodes. And in this level, we'll only consider one node. Since these null nodes are not coming in between any two non-null nodes. Okay, so in this level, we'll only consider one. So this is the maximum width in the tree. So 2 would be the answer. In this case, 4 would be our answer. In this case, 7 would be our answer. Yes. Let's just understand the intuition behind this. So what we are going to use is, since we are working on levels, we are only talking about levels, we are going to use level order traversal. Okay, I hope this is very clear in this question that since we are working on levels, we must use level order traversal in this, and level order traversal uses queue. Okay, what I'm going to do is, see, if I'm going to use a concept which is called indexing. Okay, let's suppose it's a I have indexed this parent node as 0. I have indexed this parent node as 0. So what would be the indexing of its two children? I'm going to index its children as 1 and 2. Then I'm going to index 1's children as 3 and 4. If suppose they would be children of 2 also, then I would mark them as 5, 6. Okay, so just note this thing in your mind. Just note this thing. This concept, this indexing concept will be used in many questions, and this is a popular concept of segment trees. Okay, so if the parent nodes, if you are indexing parent node as 0, then its left node would be indexed as 2i plus 1. Okay, and its right node would be indexed as 2 into index of parent plus 2. So here I means the index of parent. So if parent's index is 2, then by this formula, left's index would be 1. If parent index is 2, then its rightmost children's index would be 2i plus 2 will be 2. Since we have 2 into 0 plus 2 will give 2. And in a similar way, if you try it for this tree, then the similar indexing would be there. Okay. if this concept is new to you, I want you to write it somewhere and test it on different trees, because this concept will be used in many questions of trees and is a popularly asked questions, and it is used in many popularly asked question, and a very it is a good concept used in segment trees. Okay, so if I use this approach over these examples, then I'm indexing parent node as 0. By this example, by this formula, 2i plus 1, its left children would be 1, indexed 1. By this example, its 2's right children would be indexed as 2. Okay. Again, if I see 1's left child would be indexed 3 by the formula this 2i plus 1. Okay, 2 into 1, 2 plus 1, 3. Then this will be indexed as 4. If there would be a node here, if there would be a non-null node of 2's, then it would be indexed as 5, and node 9 would be indexed 6. Okay, similarly I can do it for these trees. Okay, so how can we conclude that, how can we come to the width from this? See, this in this level, this is the only node. Okay, let's take example of this level, level 1. Our we can find the width with a formula last minus first plus 1. Index of last node in this level, which is 2. Index of first node in this level, which is 1, plus 1. This will give us 2. Okay, so which says there are 2 nodes in this level. Let's use this formula for this level. Okay, the formula is one second. The formula is last index of last node minus index of first node plus 1. So here index of last node in the level 3 or in the level 2, what is the index of last node? It is 6. Index of first node is 1. Plus 1. This will give us 4. So, which means that there are 4 nodes including the inner null nodes. Okay. And I want you to apply this in this example. Let me also discuss this example with you. These nodes will be index 0, 1, 2, 3, 4, 5, 6. I have indexed the nodes of the tree Here in this level, I will get one node by this formula, last minus first plus 1. In this level, I'll get two nodes. In this level, since the first node is 3, the last non-null node is also 3, is also indexed as 3 plus 1. We'll not consider these terminal non-null nodes. Okay, this will give us 1. And our maximum from all of these are, from all the levels are 2. So our answer would be 2. Let me discuss the code with you. Since we are using level order traversal uses queue. Okay, so in the queue, first I'm storing the root node. First I'm storing node and the indexes. Okay, here I have stored root node with the index 0 and I'm traversing to our tree until we reach the end of the queue. Okay, if you don't know how to traverse, how to do a level order traversal, I suggest you to go and first do that. Okay, if you don't do, there are many questions which you can which you will be able to solve if you know level order traversal, which can only be solved by level order traversal. Okay, so here also you can try to understand it. I've taken the size, uh, which will say that which will give us number of nodes present in our tree currently. So there are here only one node, root node is present in our queue. I'm running this for loop until one time. Okay, since one node is present in our queue, we are running this for loop only one time. Okay, and then traverse, and I'll check its left and right node. If there exists a left node, I'll push it into the queue, and what will be its index? It will be 2 into index of root node plus 1. If there exists a right node of parent node, then I'll simply push it into the queue with the index 2 into I plus 2. 2 into index of parent node plus 2. Okay. Here, in each level, I'm storing the index of leftmost root, and index of rightmost node, and are storing the answer in our answer variable right minus left plus 1, and I'm returning the answer. Here in this question, you have to keep few things into your mind. One thing is indexing. This concept is very important and will be used many places ahead in your life. Okay. Second thing in this question is, what you could have done is you would have taken int here, and this will give you integer flow error. Okay. Oh, wait. If you try to run it this way, then this will give you integer flow error. If you submit it, then you'll see. See, it says that integer overflowed. Okay, that's why I have mentioned long in, that's why I've created these variable as long. Okay, you could have done one more thing. Let me explain you it here. If you do not want to use long, there is one more way which you can use to solve these kind of questions where you have to index the nodes and then find the answer. If you're indexing the nodes and you every time you're doing 2 into I plus 2, 2 into I plus 1, you every time multiplying the number by 2. Okay, so that could lead to an integer flow error. Okay, what you can do to manage this is, suppose you are indexing the parent node as 0, you index it 1, you index it 2. Okay, at this level you have done this much. Okay, when you come to here, you see all these nodes are already indexed, but what you do is you again take, you indexed it as 0, you indexed it as 1, and if there would be more nodes, you'll index them 3, 4. Okay, if it's okay, now you see this node will index its children node as 1, as 2, and since we have indexed this as 1 now, this node will index 1 will index its children node as 3 and 4. Okay, and suppose there would be children nodes also. Up till here, till this level, you are in this level and you have done till here. When you are coming to this level, when you are coming to this level, again you'll index these node as, you'll change the indexing of these node, and now you'll change it to 0, 1, 2 and 3. Okay, and again you continue doing this thing. What is the benefit of this is, this will not give you integer flow error, as you are not multiplying, you are doing multiplying all the nodes into 2, but see, if you wouldn't have done this, then what would be a case, what could have done is, this node will be 0, 1, 2, this node would be index 3, 4, 5 and 6. Okay, but in this case, when we are updating the indexing, in this case the index of this node is 3, and if we wouldn't have done this, then the indexing is coming out as 6. And suppose you are having a bigger tree, then this would be very prominent, this would significantly change with a bigger number. If you change the indexing, this would come out to be a smaller number, but if you don't change the indexing, this number would be significantly bigger than the changed indexing number. So this concept is used to do so this concept is used to overcome the O into integer flow error sometimes. Okay, but here changing the int into flow have worked, since there were only 3000 nodes. Okay, in constraint it's written as there would be maximum of 3000 nodes. So this has worked. Yes. So I hope you have understood the explanation, and for such content, keep visiting the channel. Thank you so much.